Okay, hello everyone in a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage and resistors. This exercise was a previous one in the brevet exams in 2015 first session, second exercise. The title of this exercise is given by resistance of a voltmeter. The aim of this exercise is to show that the resistance of a voltmeter is very large. For this, we consider the series circuit that is represented in figure 1, which is formed of. They mentioned figure 1, then now we can use it. A generator G maintaining across its terminals a constant voltage UPN is equal to 12 volts. Then the trick in solving such type of exercises is to write the given voltage on the electric circuit itself. Then the voltage of this generator is given by 12 volts, which is a DC voltage source. An ammeter A of negligible resistance, two resistors R1 and R2 of resistances R1 is equal to 10 ohms, and R2 is equal to 20 ohms, respectively. A switch K, the switch K is closed. Notice that till this moment they didn't mention anything about figure 2, then we are not allowed to use it. Now in number 1, they are telling me the voltage UPP across A is 0. Notice that across P and B we have the ammeter, and because the ammeter is of negligible resistance, then the voltage across it is 0. The voltage is 0 because it is of negligible then in this case we have that UPB is equal to 0. Now in number 2 they are telling me the voltage UDN across K is 0. Notice that here K is a closed switch which acts as a connecting wire, then the voltage across it is 0. The voltage across a closed switch is 0 because it acts as a connecting wire. Then in this case we have that UDN is equal to 0. Now in number 3 they are telling me deduce that the voltage UPN is equal to UBD, and the word deduce means that we need to use the part just previously before. However, in parts 1 and 2 we have discussed the voltage across certain branch of this electric circuit. Therefore we might use these results later on to find the voltage across another branch using the law of addition of voltages. Then indeed, if we apply the law of addition of voltages, always in physics we need to mention the law that we are using. Apply law of addition of voltages. Then how do we apply this law? Always on the left we will write the voltage of the battery, which is given by UPN, and on the other side we will write the voltages across different electric components starting from P and ending with N, and making sure that UBD, both UPN and UBD, must appear in the equation. Then from P we will go to the point B, and now from B we will go to which point? Here we can go directly to the point D, or we can go to the point D across the point C. But since they are telling me to show that UPN is equal to UBD, then we require that UBD must appear in the equation. Then we will go directly to the point D, and from D back to N. We will keep both UPN and UBD as variables. Then UPN is equal to 0 because the value of UPP is 0 proved, plus UBD plus UDN, which is given by 0. Therefore UPN is equal to UBD. Then that's it for part 3. In number 4 or part 4, they are telling me calculate the equivalent resistance R equivalent of R1 and R2. So always whenever we need to calculate the equivalent resistance, we need to mention whether the two resistors are in series or in parallel. Notice that here R1 and R2 are in series because they have one terminal in common. Then let's mention that R1 and R2 are in series. And let me say here that for this statement they give half a mark, so this is important. Now the equivalent resistance, which is denoted by Req, is equal to the sum of the resistance because they are in series, then R1 plus R2. The value of R1 is given by 10 and the value of R2 is given by 20. Because R1 is in ohms and R2 is in ohms, then the value of Req will be in ohms. Then we have that Req is equal to 30 ohms. And always whenever we calculate an equivalent resistance, we redraw the given circuit, replacing the grouping of the resistors by the equivalent resistance. Then this is the battery of 12 volts. This is the ammeter A. Now the equivalent resistor replaces the two resistors R1 and R2, therefore the point C will disappear. This is R equivalent. Let me write here that R equivalent is equal to 30 ohms. This is the point D, and between D and N we have a closed switch K. Okay. Now in part 5, they are telling me calculate the current flowing in this circuit. Let this current be I. So now for each question we have two electric circuits. Then we will refer either to this circuit or to this circuit in order to answer the given question. Now in part 5 they are telling me calculate the current flowing in this circuit. Now we will use this circuit. Because this is a closed circuit, then it will be traversed by current I. This is the current I. And now because we have from part 3 that UPN is equal to UBD, then we know that the applied voltage across R equivalent is given by 12 volt, and we already have calculated R equivalent to be 30 ohms. Then we will calculate Ohm's law to R equivalent in order to determine the value of the electric current I. Then apply Ohm's law to R equivalent. This law is given by that U is equal to R multiplied by I. Constructing the triangle of this formula, U at the top, R and I at the bottom. We are interested in calculating the value of I, so putting our hand over I will be given by U divided by R. Let's label these variables or these quantities. The applied voltage across R equivalent is given by UBD, and R is given by R equivalent. Now the value of UBD is equal to 12 because it's equal to UPN, and UPN is equal to 12 volts, divided by 30. Plugging this on the calculator will give us 0.4. Since U is in the SI and the value of R in the SI, so the value of I will be in the SI, which is amperes. Then I is equal to 0.4 amperes. And I repeat, whenever we calculate any applied voltage or any traverse current, we will label these quantities on all the electric circuits that we have. So here the electric current is given by 0.4 amperes. I is equal to 0.4 amperes. And here as well we have that I traversing R1 and R2 is given by 0.4 amperes. And now in number 6, they are telling me show that the voltage UCD is equal to 8 volts. We will refer to figure 1 to answer this equation because the point C doesn't appear on this electric circuit. Now we know the electric current traversing R2 and we know the value of R2 to be 20 ohms. Then we can calculate the voltage UCD using Ohm's law. Then number 6, applies Ohm's law to R2. Now U is equal to R multiplied by I. No need to construct the triangle of this formula because already it is in the form that we want. We are interested in calculating the voltage UCD across the resistor R2 traversed by the current I. The value of R2 is given by 20. The value of I that we already calculated is given by 0.4. Plugging this on the calculator will give us 8. Since I is in the SI and the value of R will be in the SI, so the value of U will be in the SI, which is volts. Then UCD is equal to 8 volts. So here we have that it is 8 volt. Now in number 7, they are telling us that we connect between C and D a voltmeter V that can be considered as a resistor of resistance R as shown in figure 2. Then they mentioned figure 2, then now we can use it. Here they are telling me that the voltmeter can be considered as a resistor of resistance R. So the voltmeter is a resistor of resistance R. And this means that we can apply Ohm's law to the resistor, to the voltmeter, sorry. Okay, the current flowing in the voltmeter is I prime is equal to 0.01 milliamperes. Now in part A, knowing that the voltage UCD remains 8 volts, which is across the resistor R2 and the voltmeter, calculate the resistance R of the voltmeter. Then we need to calculate the resistance R of the voltmeter, and this can be done using Ohm's law. Here we are applying Ohm's law to the voltmeter because they are telling me calculate the resistance R of the voltmeter. Knowing that, we know that reverse current is given by 0.01 milliamps and the applied voltage, which is given by UCD across the voltmeter, is 8 volts. Then this law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, U at the top, R and I at the bottom, we are interested in calculating the value of R. The voltmeter has an applied voltage UCD and a traverse current I prime. Now let's convert I prime to the SI because it's given by 0.01 milliamps. In order to convert milliamps to amps, we divide by 1000. Then dividing 0.01 by 1000 will give us 0. amperes. So here we have 4 zeros. Then the value of R is given by 8 divided by 0. Then plugging this on the calculator will give us 800,000. So notice that in this case the value of the resistance is very large. Now in part B, deduce that the calculated value of R satisfies the aim of this exercise, and the word deduce means that we need to use the part just previously before. In part A, we have determined the value of R, and indeed R is very large in this case. We are get used to the values of R to be between like 10 ohms, 20 ohms, at most 1000 ohms, but not 800,000 ohms. Now, if we refer back to the aim of this exercise, they are telling us that the aim of this exercise is to show that the resistance of a voltmeter is very large. then in this case the aim of this exercise has been satisfied. Since has been and by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.